Hi there, in this video we're going to learn about similarity and transformations. Your objectives for today are to use a series of transformations to identify similar figures, and to use a scale factor to create similar figures. First, let's begin by identifying similarity. A dilation changes the size of a figure by the scale factor. Pre-image and your image are not congruent, and two figures are similar if the second can be obtained from the first by a sequence of transformations and dilations. So if there is a dilation, then your figures will definitely be similar. Okay, any other transformations, they'll be congruent. But if your series of transformations includes a dilation, then your pre-image and your image will be similar. Determine if the two triangles are similar by using transformations. Explain your reasoning. So here is triangle EDF and HGI. We see that one side's length is 5 and the other side's length is 10. All right, let's first start by looking at orientation. So if we remember from the previous video, orientation is very important. Orientation tells us a little bit about what transformation has occurred. So here, the orientation is the same. The triangle looks like it's upright. Nothing is turned, nothing is flipped. Okay, so since the orientation of the figures is the same, one of the transformations is definitely a translation. Alright, step 1. Let's translate triangle DEF 1 unit and down 1 unit and 5 units to the right so that D maps onto G. Okay, so you can really pick any one of these points. In this case, I'm just going to use D and G, but you can use F. You can go from F to I or E to H, as long as you move the triangle so that it lands on one of the points. Okay? As long as it lands not on one of the points, but on one of the corresponding points. Like E corresponds to H, F corresponds to I, and D corresponds to G. They're in the same position. Okay? So let's start. We're going to map this vertex, angle D, onto angle G. Okay, so we're going to translate it by going 1 down and then 1, 2, 3, 4, 5 to the right so that D maps onto G. Now you're going to write the ratios that compare the lengths of each side. Well, HG. Okay, HG is 1, 2, 3, 4, 5, 6, 7, 8 over ED, right? HG side corresponds to ED. So 1, 2, 3, 4 over 4, or 2 over 1. Let's compare the lengths of GI to DF. GI, 1, 2, 3, 4, 5, 6. So it's 6 over 1, 2, 3. 6 over 3, which is 2 to 1. And let's see IH over FE. So we're comparing IH, which is 10, over FE, which is 5. Okay, which is also 2 over 1. So since the ratios are equal, triangle HGI is a dilated image of triangle EDF. So the two triangles are similar because a translation and a dilation maps EDF onto triangle HGI. Okay, just in case we're unsure, again, let's look at this. You start off translating, okay? You can actually translate this triangle, 1 down and 5 right, so that it maps directly onto this triangle. Or I should say directly onto the corner of this triangle. And then you would dilate it by 2. So you would just multiply each side by 2 in order to get this triangle. Let's look at another example. Determine if the two rectangles are similar by using transformations. Explain your reasoning. First, start by looking at the orientation. Okay, well here it looks like we have a rectangle that's longer horizontally. Here we have a rectangle that's longer vertically, okay? So the orientation of the figures is different. In this case, it's turned, right? So it's a rotation. Okay. Step 1. Rotate the rectangle VWTU 90 degrees clockwise. Again, clockwise goes around like a clock, right? So this rectangle is moving 90 degrees clockwise. So that W is oriented the same way as rectangle WXYZ. And then step 2, you would just write the ratios comparing the lengths of each side to see if they are similar or not. Let's start comparing WT and XY. So WT and XY, the two longer sides. Okay, WT is 1, 2, 3, 4, 5 boxes across, and XY is 1, 2, 3, 4, 5, 6, 7 boxes up. So 5/7. Let's look at TU and YZ. Okay, because TU corresponds to this YZ. TU is 1, 2, 3, and YZ is 1, 2, 3, 4. So far, no good. They are not the same ratios. Let's look at UV and ZW. So UV versus ZW. Okay, well, UV has to be the same length as WT, which we said was 5, and ZW has to be the same length as XY, which was 7. And now let's look at VW versus WX. Well, VW would have to be the same length as TU, which we said was 3, okay, and it would have to be the same length as YZ, which is 4. So, well, the ratios are not the same, okay, they are not equal. You have to have equal ratios in order for them to be similar figures. So here, the two rectangles are not similar since a dilation did not occur, okay? A dilation did not occur in this instance. You could also use a scale factor. Similar figures have the same shape but may have different sizes. Size is related to scale factor. That's just something for you to recall from the last lesson. Scale factor is greater than 0, but less than 1, then it's a reduction. If the scale factor is greater than 1, then it is an enlargement. Okay, triangle ABC has sides that are 12 feet, 16 feet, and 20 feet in length. It is related to triangle CDE by a scale factor of 0.5. What are the lengths of the sides of triangle CDE? Alright, so first thing we know is that the scale factor is 0.5. And we also know each side length. So in order to find the new side lengths, we're going to multiply each of the sides, by 0.5. Okay, so 12 feet times 0.5 gets you 6. 16 feet times 0.5 gets you 8. And 20 feet times 0.5 gets you 10. So the lengths of the sides of the triangle CDE are 6 feet, 8 feet, and 10 feet. Okay, so all we do is multiply each side by 0.5. This way, now, they all would end up being literally half the size. Let's look at our next example. Ken enlarges the photo shown by a scale factor of 2 for his web page. Then he enlarges the web page photo by a scale factor of 1.5 to print. What are the dimensions of the print? Are the enlarged photos similar to the original? Okay, so we're going to start off by multiplying each dimension of the original photo by 2 to find the dimensions of the web page photo. Okay, so first he enlarged it by the scale factor of 2. Okay, so let's begin with that. We have 2 inches by 2, which gets you 4 inches. And then we have 3 inches by 2, which gets you 6 inches. So then the web photo will be 4 inches by 6 inches. Now we're going to multiply each by 1.5 to find the dimensions of the print. So when we do that, we get 6 inches by 9 inches. So the printed photo will be 6 inches by 9 inches, and all 3 photos are similar. Which case there was a dilation.